So, welcome everybody to this evening's meeting of the British Astronomical Association GNU Radio Group. I hope you're all ready for Christmas, and I hope you all get whatever your Christmas wishes are this year come true, particularly if it involves an enormous dish being delivered on a big flatbed lorry to your front yard. And if that happens, I hope that the other half of your household is not angry about its delivery. Anyway, we're very fortunate this evening. We've got Andrew here, Andrew Thornett, who's going to be leading most of the evening, and I'm going to pass over to him now, and he's going to be giving us a talk about some of the theory behind GNU Radio and how it works, and it will follow on well, I think, from what we did at the last meeting. So passing over to you now, Andrew.
Okay, thank you. I apologise straight away because I've got a bit of a throat, but I will do my best. We're going to look at Chapter 5 from the book on Practical SDR today, but before we start that, I'm going to...
So sorry, Andrew, to interrupt you. If I could, just for the sake of anybody who has only just started looking at these videos, just remind you that we do sort of have a bit of a course textbook, which is this one here, Practical SDR, by David Clark and Paul Clark. So we've been sort of following this as a way of getting to grips with both software-defined radios and GNU Radio, which is what this concentrates on, with lots of practical examples. Sorry to have interrupted you there.
Sorry. That's okay. That's okay. So,
I think we might have a bit of feedback, so perhaps if everyone else mutes their microphone, that might be quite good. It might help.
Okay. So I'm hoping you can see the screen now. Obviously, I can't hear anybody else. So let me try going back.
Yes, we can see it well, and hear you well as well.
All right, excellent. Right, so before we get into Chapter 5, I thought I'd go over a bit that Andrew and I were discussing privately about bandwidth, resolution, and sample array. So this is just a simple FM receiver. And so if I run this flow graph and show the results here, so at 102.4 megahertz here in the UK, that's Heart FM. So that peak there is Heart FM. And obviously this has got various sliders on that you can do things with. But at the moment I'm running with 128 points across this window. So the sample rate in this flow graph is 2 megahertz, and so it's 128 data points are being spread across that entire 2 megahertz, and I'm using only 128 points to sort of show the effect. If I then stop this, I can go into RSP 1A and I can change the bandwidth, so I can set a narrower bandwidth, but when I rerun it, what you'll find is that this area here, this 600 megahertz in the middle, is what the receiver is concentrating on. It's basically ignoring the rest out here, but it is still filling the entire sample rate with data points. So using bandwidth doesn't increase your resolution. It just narrows the region that has concentrated data in it. So to me, sample rate is the frequency that the receiver is downloading samples, but it also represents span in GNU Radio. So now if I take the FFT size up to 1024 and then rerun it, so now you can see much better resolution there. So you've now got 1024 data points going across this 2 megahertz band, and you can see more detail in there. And so if you want to increase the resolution in your spectra, what you have to do is increase the vector length, or essentially the number of points that you have across the sample rate, in order to increase the resolution you're getting in the middle there. And you can play around with some of these things, and you can see various effects as you go along. And so, I mean, this always surprises me, that you reduce the RF gain and you get more signal in it. So sometimes you're swamping the noise with RF gain, and so you get more signal. But perhaps somebody who knows more about the gain options can talk about that, even though we will talk about gain a little later on. But so the only way that I can see within GNU Radio to actually sort of increase the focus in the middle here is to slice the data that's coming out of here and take a smaller fraction of it through the processing stream. But I haven't been able to work that out yet. So that's just an interlude to show you the effect of resolution, if you like. So if we then go on and go into chapter 5, we'll make a new script on GNU Radio, and we will make a simple tone. So for this we want a signal source, so you can follow along if you can keep up with me, and shout if you can't. So take a signal source, we want a time sync, we need an audio sync if you want to listen to it. We need a frequency sync. And we need a range. And so I'll start with the range, double click it, open it up, and we'll change this to frequency. And we want a default value of 500, a start value of 100, and a stop value of 32e to the 3, or 32k, and a step of 100. So the frequency on the noise source is a freq. Amplitude is 1, that's okay. And so then you can just join these together. And wherever you've got a red line, there's something wrong. So number of inputs is 1.
I think it might be the type of data, Andrew, because you've got different colour on the in from the out.
Yeah. So one way to change that is if you highlight the block and use your arrow keys on your keyboard, you can sometimes change that. I guess this ought to be into that way. And so the other thing I need to do is to go into the frequency, and I need to change this from spectrum with full to half. And then if I run it, I want to save it as a name, so tone. If I could type, it would help. Okay, so that's what you get. And so it's a simple sine wave with the signal down here. Now, with these plots, what you can do is you can draw and box and zoom in, and then if you right click, it will zoom back out again. So if you want to inspect something, you can draw a box around the area you want to look at and zoom into it, and then just right click inside the graph and it will zoom back out again. And so if you want to move the frequency, you can see as you move the frequency, it shifts along the frequency spectrum, and you get the corresponding change in the time signal, because you're changing the frequency. So you can see how that works, and that's a single tone. So I guess I'll go back here. What they were trying to do in this was again show you that is a very broad signal, and that is a very broad signal because of the number of samples that we've got going across here. We've got 1024 samples across the entire window, and if we go up to 4096 and run it again, you can see it's a much sharper peak, so you get a better resolution because you've increased the number of points across the window that you're looking at. And so again, that's an example where if you want to get the resolution, you can increase the number of points that you're using. Obviously, that increases the workload for the computer to do, because everything downstream is handling more points. And so that was a simple tone. But now what we'll do is we'll add two more signal sources. So I'm just going to Control C and Control V twice, add two more signal sources. Get rid of these arrows. And then we want to put in an add. We want add rather than add constant. Double click it. We want to change it to 3 inputs. And change it to a float. And then we want to take all 3 of these to here. And then you can take the outputs to these 3 again. To a file, save as, and change the name of this to chord. Let me know if I'm going too fast. And then they do it as individual frequencies, but I find it just easier to play around with ranges. So we'll do these, add 2 more ranges, and then we want frequency 1, and we'll make the default value on frequency 1 1318.5, and then make this second one frequency 2, and we'll make the default value 1568. And we'll change the default value of the first one to 523.5. And then when you run that, something not quite right there. Oh, that's what I have done. I haven't changed these. This one's frequency 1, and this one's frequency 2. There we go. And then if you run that, what you get is the 3 peaks here, and that is the chord. Now, for this example, we want to go back here to 1024, just to make it more obvious what's going on. So you've got the 3 peaks here making the C chord, I believe it is. But as I say, you can then zoom in on these and you can see the 3 peaks. And then you can see the pattern up here from those 3 peaks going along. So you can play around with the sliders and make different tones if you want to. But this is then a model we're going to use in further demonstrations, looking at gain and also looking at filters. And so we then go on, if we want to look at gain, and do a new GUI. Again, we want a signal source. We want time sync. We want another time sync, we want 2 time syncs. We want to multiply. Oh, sorry, I got the wrong one. We want multiply constant. That's it. And audio sync if you want to be able to listen to it. And the final thing is, again, arrange. Now again, just click on them, press the down arrow, and you can change them down to float, or you can double click into them and you can change the drop down to float. So on the signal source, we want frequencies of 1,000, but we want amplitude. We want amplitude down at 0.01. That can then go into the multiply. The range is going to be the gain value. Default is going to be 1. Start is going to be 0.1. And the stop is going to be 10. And the step is going to be 0.1. And then in the multiply const, the constant is going to be gain val. Gain underscore val. And then that can go out. The blocks, and then this time sync goes into there. So you've got 1 time sync before the multiplier, 1 time sync after the multiply. And then if we run that, this is gain. I'll call it gain 1 because I've already got one called gain. And so you can see the pattern, and then if you increase the gain value, it doesn't seem to, oh yes it is, there it is. You can see that the one after the multiply constant increases, reduces as you move the slider up and down. So you can take the gain lower than the default or higher than the default. And so that's the effect of gain on these. Now, a different way of looking at that is to then add a frequency sync. In this case, I cheat. Again, I'll hold the bottom down key to make it float, but I will change the number of inputs to 2, and then take first input from before the multiply and the second input from after the multiply. Again, we need to go in there and change this to half, and then if I run that, what you can now see is that you have the frequency shown down the bottom, and if I change the gain, if I increase the gain, you can see how the original is the blue, and the after the gain has been added is the red, and so you can see how that gain increases, or in fact decreases if I go the opposite way. It can reduce it, and so that's how you can make the peak larger or smaller by using the gain. And it turns out that increasing the amplitude by 10 gives a 20 decibel increase in signal strength. So that's the effect of gain on the signals. So then we get on to filters. I hope I'm not going too fast. New GUI. What I'll do is I'll open chord, and then I'll save that, save as filters. Save having to build everything again. I'll just shift the add over, and I'll delete the arrows. And now what we want to do is we want to add in a low pass filter. Again, just highlighting it, click down arrow and change it to floats. So now I'm going to add 2 more ranges, so I'll Control C and then Control V twice to add 2 more ranges. And the first range I'm going to do as cutoff underscore low, and cutoff low, the default is 10 e to the 3, start is 100, and the stop is 10 e to the 3, so 10k, and the step is 10. So 10,000 default value, 100 start, 10,000 stop value, step is 10, and then the second one I've added I'm going to call transition width. And for that we want a default of 1000, a start of 100, a stop of 10,000, and a step of 10. And then in the low pass filter we want the cutoff frequency to be cutoff low, the range we just defined, and transition width is the transition width we just defined. Obviously can't spell. That's what it is. There we go. Okay, and so then once you've got all that built, you can run it. And what you can see is you can see the signals again. This is the chord that we had previously. And you can see all three peaks in the chord are still present. And that's because at the moment, the cutoff frequency for the low pass filter is higher than the frequency of all three peaks. And so if you then start to reduce the cutoff frequency until you get down to 1500-ish, you can now start to see it's starting to affect these two peaks here. And we can keep going a bit further, and you can see how they're being reduced. And so that's the cutoff frequency is focusing on this one because it's 523 megahertz, that peak, and it's cutting out these. And it doesn't cut them out completely, but it reduces them dramatically in terms of their signal strength, so that if you are listening to this tone, you wouldn't be able to hear these. And so that's the cutoff, and you can increase it. But what you'll find is you'll find difficulty in separating these two peaks. And so that's going to be an example we'll do when we add the high pass filter. But as I say, when you come up beyond the frequency of these, you get all three peaks back again. And so you can fiddle around with these, and you can see as you change the cutoff, you can see the difference in the peak shapes as well as you're changing the chord back to a single tone. And a single tone is then just a sine wave, or cosine wave in this case. So that's the low pass filter. I'll stop that. I'm just going to move these over here a bit. And what I'm going to do is I'm going to disable that. So right click on it and click disable. And then we're going to stick in a high pass filter. So with high pass filter, stick that in here. And so then again, I'll down click it and change it to float. Take the output to the input, take these outputs into here, and then I want another range, and instead of cut off low, this is going to be cut off high. I think the ranges are the same. Oh, the default is going to be 100. Start is 100, stop is 10k. Yeah, that's okay. So we'll start that. And then we just need to change these and put this is going to be cut off high. And this one's going to be in transition width. And hopefully that's all right. Okay, and so then if we run this, right, so again, you can see that we are seeing all three peaks, and that's because the high cutoff is less than the lowest peak. And so if I start to then increase the high cutoff, you can see it's already starting to affect this peak. It's starting to reduce. And so I keep going, and it's starting to affect this one as well, because we're at 1810. So it's starting to affect all three of them actually, because that's beyond. It's 1568 was this one. But again, what you can see is that as you're coming in here, between this one, which was 1310, 1523 or something, and this one's 1568, you can't split those two peaks because they're too close together, and the slope of the filter, so the filter isn't a square edge, it's a sloping line, and so the sloping line means that it's cutting off this one more than this one, but because of the slope of the line, it's affecting both these, and so that's what the transition width allows you to do. So if you reduce the transition width, you can see how it's affecting this one, and you're actually splitting these two peaks out of this one, and now you're getting the highest tone as more or less a single tone. And so that's how you can play around with these things in order to improve your signals. You change the cutoff as well as the transition width, so the slopes or steepness of the slope of the change, in order to be able to split some of the peaks. And so that's the high pass and the low pass filters. And in fact, what you can do is you can re-enable this one, so you can enable it again, but then what we need to do is we need to take these three lines out of here, take this arrow out of here, and take the output from the low pass into the input from the high pass, and then you can play around with all three of them, or all of the filter options to your heart's content. So you can start playing around. And seeing the effect. Reduce the transition width, and you can see how much it improves, cutting out the before and after signals and just leaving you the middle signal. So once you build things you can play around with them, and you can see the effect that they're having, which then gives you insight as to what you're building next. And then the final one we've got is I didn't title it. So save this one again, save as, and this is C major underscore BPF. Oh, bandpass filter, that's what it is. That's what it is. Right, so we can remove these two filters, and what we now is a bandpass filter. So bandpass filter. Again, down arrow on the keyboard a couple of times and get it to the right color. Wire it up. And now we want so cutoff low. One default value is 200. Cutoff high 2000 default, and transition width default is 100. That's fine, but we need to add these into here. So cutoff low is cutoff low, high cutoff is cutoff high, and transition width is transition width. And again, I obviously can't type. Transition, there we go. And so that makes the C major chord. You can then run that, and again you've got the same three signals. I'll zoom in a bit on them. and then you can start playing with the cut off high, bring it down, and you start to affect the last two peaks. Cut off low, you can bring it up, you can start to cut off the first peak, but in order to make it much better, you need to reduce the transition width, and then you can again fiddle around with these things. So instead of having two filters to achieve the result of isolating the middle peak, you can use the bandpass filter, which does the same thing. And so to me, the bandwidth that we were looking at right when I started is much the same as using a bandpass filter. It's in the GNU radio, and it filters out the middle portion, but it doesn't offer you that middle portion as an entire spectrum. It still leaves that middle portion in the middle of the complete frequency range of your sample rate. And so if you want to increase resolution, you have to increase the number of points that you're looking at here. So that was a quick rundown of chapter 5. I hope you managed to follow on. I did that rather quick, but I'll come back. Do you want me to stop sharing?
Oh, well, thank you very much, Andrew. That was marvellous. Gosh, for those that don't know, chapter 5 is about 50 pages long, so that was a very impressive walk through that. Is there anyone who'd like to ask any questions or make any comments? Please feel free now.
I'll stop.
Dave Bracey here. I just had one comment. I did try to do some of chapter 5, and I've managed to achieve the frequency graphs that you achieved, Andrew. When I played sound, my laptop, all I get is like a lot of white noise. Now, maybe that's something to do with my laptop. The frequency graphs I was getting look very nice. Everything else looks good. Just apart from the noise coming out of my speakers was horrendous. I don't know if you got any comments on that.
That could be due to the sort of audio sync not matching with the hardware that you're using.
Sorry,
Okay.
Andrew, you're quite quiet. Are you a little bit?
So it could be to do with the audio sync not matching quite with the hardware that you're using. When I used the FM radio, I had to put in extra things in order to get the sound coming out on my PC. But for the demonstrations here, I'm using a remote desktop to a separate PC running Ubuntu, which has got the applications on, and that's actually got no speakers, so I'm not getting any sound from it there. It's only when I use this laptop with a USB dangling off or hard drive dangling off the USB, that I get sound out of this laptop. So it does work, but it may be fiddling around.
Yeah. Okay, that's brilliant. Thank you very much, Andrew. That's a good explanation. Something to play around with. Thank you.
Do you have it on your computer there, Dave, that you could show us? If you have the GNU radio script that you created, and perhaps we could see whether there's an obvious error or whether it is likely to be a sound card.
Right, okay. Yeah, sure, okay. Right, okay, I'll share my screen, shall I?
Yeah, go for it. Well, or more accurately, maybe Andrew can tell us whether there's an obvious error or not.
Okay, all right, I'll share screen. Hopefully that's screen 2 shared now. So there's the script. I'm going to play this.
Not at the moment.
Did I get the wrong one? Okay, let's try. Sorry about that. Let's try sharing the other one.
We're not getting any of your screens at the moment.
Okay. All right. I'll.
Does your computer say that you're sharing?
Because I haven't pressed allow. That's why.
Oh. Here we are. It's come up now.
Now I'm going to press play now. Yeah. I don't think they hear me. Here we go.
Yep.
Stop that. Maybe you heard that.
Well, if you play it so we can see the time sync and the frequency sync.
Oh yes, of course.
But you okay.
Oh, okay.
Stop.
So if you go into double click on the frequency sync. Double click on frequency sync. Right, change the spectrum width from full to half.
Yeah.
Okay, now try it.
Okay. Yeah, so you can see I had quite a nice frequency bit looked great.
I mean, you were very quick closing it down. Did you actually get that?
It was just the noise. I was trying to avoid blasting you with the noise.
We couldn't hear it.
Oh, you couldn't?
No.
Ah. Oh, okay. That's interesting. I'm getting like a massive wall of white noise hitting me. I'll put up with it and show it to you.
Right. So, I mean, looking at that trace,
that's fine.
Yeah.
My guess is that it's to do with the way that GNU Radio is putting the audio out into your computer. It isn't coming from where you think it is. It's
Okay.
like when you use a microphone, you have
Yeah.
to change the settings. So I think you need to explore the settings of the audio within your computer to find out where that audio actually is.
Okay, great, thanks. And that probably explains why I couldn't hear you guys at the start either. But I mean, it's probably not a problem to me because I'm not looking at, listening to sound anyway.
Yeah.
Want to understand this.
Before you do anything else, or before we just, I'm sure that Andrew's right there, but before we just say that's what it is, can you go to the sample rate variable and just change that to 2M?
Yep. This one?
Yeah.
To 2M.
Yeah. Or
How do I do that?
Or 2E6 will do.
Oh, okay, to the value you mean?
Yeah. 2E6.
2E6. Yep. Okay.
Yeah.
Okay.
Just see what happens when you run it now.
Ooh,
Oh, no.
I've got red now. I've done wrong.
Doesn't work that. Well,
It can't cope with that value.
fair enough. Okay. That isn't going to work then. Forget that.
Okay, alright, cancel that. Okay. Thank you very much.
Yeah. Of course, it can only go up to the sound card's rate, maximum rate, can't it?
Yeah.
Yeah. Okay, thank you.
Okay. Well, I don't know what's going on there.
I'll stop sharing.
If you cancel that, just go to the back arrow. That will undo it.
Oh, okay, yeah, cancel that. And the back arrow, yeah. This one?
Yeah, that's it. Couple of times. There you go.
Brilliant. Thank you. Okay. I'll stop now. Thank you very much.
Yeah. Okay. How about anybody else? Any other comments or thoughts on that presentation, or anything you'd like to add on the signal processing part of it? Okay. Well, I would like to make a suggestion. So I'm going to paste two assignments into the chat. I could send these out afterwards as well. What do you think of those assignments, Andrew? Do they seem reasonable?
Yeah, Just scanning down them.
Again, completely optional for anybody who just wants to just take it a little bit further and do something for themselves.
So would that be five different GNU scripts?
No, that's not the idea.
Is this something more complex?
It's like the chord where you've got 3 signal sources. It's just 5.
Yeah. Okay.
But it's obviously this says 5 chords, but it doesn't have to be 5 chords. But it's just the idea is you can almost make yourself a little, a little bit of an electric piano where you've got 2 or 3 different choices of chords that you can play. Again, I suppose the simplest way would be able to use the script that Andrew created and sort of multiply the inputs by 5 times and look up the frequencies for 5 different chords, or 3 chords, or 2 chords, whatever you fancied, and then find some way of selecting between the 2 of them.
Okay, sounds interesting.
And the second one is just the idea is just to make a simple AM radio. I asked ChatGTP to put the assignment together for me, told it what I wanted, and it's come up with a lot of complicated stuff around it to sort of define the assignment. But it simply boils down to the idea of just playing around and just trying to create basically a script for yourselves, one or both, or if you want to do something slightly different, that's fine too. I'm just trying to encourage people to take this a little bit further and start creating their own scripts now, so that we can start putting into practice some of these things that we're learning. If you wanted to do something completely different, that's absolutely fine too. I would recommend, if you haven't yet got the Practical SDR book, that you do get hold of a copy of it. I think it's definitely worth it to follow through on this. And
are you on commission, Andrew?
I'm not at all. I get nothing at all for it. I didn't write it either.
In the chat, I talk about 40% off until January 2 on the book.
There we are. nostarch.com/practical SDR. So that's that's electronic version of the book, isn't it, or e-version of the book? I think, is it, or is it is that also the published version as well?
You get to choose, yeah.
Oh, okay. You're going to have the paper version as well.
So, is there a way to save the chat here?
When we finish the meeting, then you can press a button at the bottom to save the chat.
Thank you.
But I've also opened up the chat now, so that link is going to be in the video as well. Okay.
Not to encourage cheating, but you can download solutions too, I think, whether you purchase the book or not, I think. But if someone gets really stumped, that's a possibility, I think.
Yeah. I mean, it's worth saying that these 2 assignments are not out of the book. I've just made them up.
That's good.
I haven't even worked out a solution to them yet myself, so I'm going to have to sit down and try and see if I can do it myself. But yeah.
I'm sorry, Andrew. How did you say you can save the chat?
There is a button. I think once the meeting's finished, at the end you'll have an option to. If you look in the chat at the end, there's a chance to save it.
Oh.
I'm looking at the moment, and I can't see it at the moment. So I think it must be once the meeting's finished. But either way, I have the chat open at the moment, so that link is actually going to be in the video. But if for individual bits, you can just just do a drag and select on any part of the chat that you want. So if you want to just take out the assignments or something, you can do that now. But I'll send the assignments out to everybody afterwards anyway.
If you right-click on the chat icon at the top bar, it gives you the option of save as or print.
Does it?
It's not working for me.
It's not working for me either at the moment. but it may well do at the end, as I say. I'll try. I'll try and grab the chat anyway and send it out to you if I can. Okay. So, is there anything else that anyone would like to talk about with regard to chat? Sorry, chat. We're talking about GNU Radio tonight, or any thoughts or anything that they've been doing in relationship to it that they would like to talk about. Ted, how about yourself? Anything you'd like to talk about?
No, I thought this was fun, and I love the trick about highlighting the small box and then down arrow to change the variable type, the input type. Thanks.
Brilliant. Tyson, have you got anything that you would like to add tonight?
Well, I was just a little confused as to how the program works when we set like in the QTGUI boxes. Is it just when the flowchart just knows to refer? I mean, like, because you can set frequency, you can set, I guess, gain. Are there just sort of standard things that you can set? I mean, it's not endless. I mean, I guess you could do volume, but it just so happens that it's in the code or it's in the program that it knows to refer to those things.
Each of the blocks is a bit of Python code that does a specific function, and then you just combine these blocks which have the Python code in them in order to build up what you want to achieve.
Okay.
It just saves you having to write out all the Python code itself.
That makes sense. And it's just the code base is just includes these sort of standard functions for radio processing and sound processing.
Yeah.
Okay.
Yeah. Once you press the play button, it creates a Python script that has all of that code in it. So when you go back into the folder where you saved the GRC, you will also find under the same file name a file named Py, which is that Python script that you can then run without having to use the GRC.
Okay, thanks. That makes sense.
Yeah. So if here you can see, should be able to see on the screen a GNU Radio script. So if we perhaps open the time sync here, you have a number of different settings, such as the number of points. But pretty much, let's say this number of points here, it tells us that's an integer, int at the end, but we could change that if we wanted to a variable. I apply that, and then I create I want a variable. So let's create myself a block, set up the variable here. This is just setting up a variable. It's got to give it the same name so that it knows what it's talking about. And that's, sorry, I used capital P. So you can see now that that's the red that was on there saying error has now disappeared. That's because I've set up a variable called points, and that defines the number of points. This actually is pulled across the value of that variable. As far as this script is concerned, it's got no idea what it's actually doing. It's just a variable. And if I now change that value to 10, press apply, you can see that number of points on the time sync is immediately changed to 10. So variable sets a value of a variable which is in the script, and then when you compile it by pressing the execute, the play sign, then it will turn it into an actual value that's used by the script. If you use variable itself at the variable block, that's a one-off that's set before you actually run it. If we instead change that to a GUI range as we were using earlier on today. By the way, you can turn off any of these blocks by right-clicking on them and then pressing disable, and you can right-click on them and then enable them again if you want. But I'm going to disable it now, so that allows me not to have to delete it, but I can just make sure it's not working. And if I now go to this GUI range here now, left-click on it to open it up and change the name, this time to points. This is now pulled through the default value that was on there of 50. It's using the time sync of 50, and the GUI range would now give us a window once you run it, which would actually allow you to pull a slider back and forth to actually change the number 50. So it's just a question of setting variables. So anything that's in any of these blocks can be actually changed into a variable. Here we've got sample rate set, we've got center frequency here, which is just set as 1,000 again. I could change that to a frequency if I wanted to, make it into a variable, and I could set up another range, pull that across onto there, and this time I could change that to frequency, and that's just setting another variable up which now controls that frequency. If I pull it back up, you can still see frequency. It's already pulled the value across, which is now 50, but again, if I was running this, I'd have a second slider now which I could pull across to change the frequency. And you can do it with anything that actually has basically a value. It just has to have the same type of data going from one block to another, which is where the orange bit comes in, because we've got in terms of data, we've got this float data here, complex message, float message, all sorts of different types of data, which I'm sure we'll address as the meetings go on. So I hope that's helpful.
But all of those blocks just compile down to a Python script in the background.
Okay. Andrew, have you done any more experiments with collecting data?
Not as yet with this. I've been doing trying to get a coaxial relay to work, switching on and off a 50 ohm dummy load as an alternative way of actually dealing with the frequency response on an 8 megabyte, sorry, 8 mega samples wide, or 8 megahertz, sorry, wide sample from the B210. But I'll talk about that in the hydrogen line meeting. But at the moment, I haven't done much more with the GNU radio yet.
What file formats does it? Can you choose different, for capture? Can you choose whatever standard you want?
There are limited file formats within the GNU radio itself, but you can easily write a Python block to write it out. So if you've got the GR Radio Astro, they've got CSV file syncs, but what they tend to do is they tend to write out individual files for each spectrum, and Ted and I don't particularly like that approach, so we prefer to have a file and tabulate the data, but they're just Python scripts, so they're relatively easy to write yourself.
Okay.
Because you've written one to save data in easy radio astronomy format, haven't you, Ted?
Yeah, I have. I hesitate to make it public and then have to even support it. But there is one out there already from Pierre Terrier from France, and so that has been working. I think there's a problem in the format, though, that I had to fix. And so if you need Ezra format, come talk to me, I suppose, for GNU Radio.
Okay. So, who haven't we spoken to? Brett, is there anything you'd like to add or speak about?
No, other than, well, I guess one or two things, but thanks, Andrew, for your presentation. It was great. I was going to just point the group at a couple of websites, one of which, Andrew, I'd given you already, as some, what I think is some good background information on digital signal processing. So I might just quickly share those so people can have a look.
Go for it.
Okay, so this is the first one. These lessons, as they're outlaid here, are a series of YouTube videos. So when you click on one of those, so if we look at digital signal processing, for example, it'll take you into a YouTube video that you can watch. So they're quite substantial. They normally run for, I think, the best part of an hour or more. But I find that they're quite good. The second one I was going to share is this one. Again, a whole series of, this one's more targeted at SDR, I guess, but it has a DSP component to it as well. But again, we look at complex numbers, for example, you get to see a video. These videos are a little shorter, sort of half an hour, 3/4 an hour, something like that. But this guy in particular is, I find, quite good at explaining the concepts behind DSP and SDR. So I've been through most of these. I think they're quite useful. So yeah, that might be interesting for people to have a look at.
Oh, brilliant! Thanks, Robert, very much for that. That's fantastic. Okay, Adrian, anything else you'd like to add?
No, actually, I just, let me see if I can get to this. Oops, I guess it doesn't work. I was just basically going to show I just received the Practical SDR book this last week. I had purchased it from Mr. Base's online shop. And it took forever to get here, but I finally got it here last Wednesday, and I haven't really had a chance to get into it, so I guess I'll have to be going back over the recorded videos here and try to catch up and see what I can get from the text. But I was just wondering on those two sites that were shown. Is there any way you could put the link to those on the chat? And I'm sorry, I didn't quite catch who was recommending those two URLs.
Yeah, no problem. I'll stick them in the chat spread.
Oh, I guess that was what, Tyson? Okay, thank you very much. I appreciate that. Yeah, I've seen the Hack RF, what was it, Great Scott site before. I haven't really gotten into it, but some of those, a few of those films, and yeah, I agree with you. They're really very instructive. But I guess that'll be very interesting. So no, I didn't have anything else to show except that I finally did get the book, so I'll be able to catch up on what's happening. And wish I would have caught the 40% off there that Ted showed, but anyway. So that works for me. But thank you very much, Andrew, for the presentation. That's I think that was very clear, and hopefully going back over the recorded video here, I'll be able to catch up with you guys. So thank you.
Yeah. Can I say, Adrian, I paid the full price for the book as well, so you're not allowed, and I think it is a very good book and worth the full price. But just very lucky if you can get it at a cheaper price.
Yeah, just glancing through it, I agree with you. It's going to be very instructive. I mean, it takes a bit of depth to get into the GNU radio sort of format. And I did have one question. Back over to Andrew, I guess. You say each one of those blocks is actually a Python script, and I was just curious: is there any way you can open those and see what the script itself is?
Yes, you can. you sort of have to delve back into the program and find the Python file where they're stored.
It's saved, Andrew, next door to the GNU radio script in the same folder.
Yeah, but if you want to examine the boxes themselves.
Oh, I see what you mean.
Yeah.
Yeah, I see what you mean.
So each one of those is an individual file that you can open into to see the actual Python script.
Let me go and let me go here. Right, I can show you with the not that activities. Bring up the file manager. Right, so if I go in here, right, so what was the one we were just looking at? We were just looking at C major BPF. Oh, I don't know where that's gone. Right, so here's one that I've created that I've got equalizer and equalizer Python. So that's the GRC file. So equalizer here. So that's what it looks as a GRC file. But when you run it, it then creates this Python file, which has all of the blocks sort of embedded in them here. So that's one way of looking at it. But I can show you from GR Radio Astro. If I go here, then there's a folder called Python, and then Radio Astro, and these are all the blocks that in GNU Radio, if I get rid of this, and I come here, Radio Astro, so all of these blocks that you can just grab and put on the screen are in these Python scripts here. So if you want to look at the integration one, this is the script for the integration file. And so it's, you know, if you want to learn how they've done it, you can get this out and figure out how to do it. So all of these will be buried somewhere on that computer. But I couldn't tell you exactly where to navigate to find a type converter, a character to float file. But they are all here somewhere. So yes, you can find them. And what you can also do is if you then go to Python, you can bring a Python block up, and if you double click it, opens up. Double click the editor. No, this is screwed up again. Quite often when I open up this, it's asking me whether I want to use a default editor, but the question is behind this window, and so I can't get at it. I'm going to have to close all of this down, reboot it in order to get behind here. So that's one of the bugs I've got, but there's no way of moving this out of the way to get behind it to answer the question. So I will stop sharing again. That's addressed your question a bit.
Okay, I see what you're getting at. Well, thank you very much. I'll kind of maybe dig through it eventually, and it'd be nice, I think, to just like you said, take a snapshot of how the actual code accomplishes the function of the blocks. I was just curious if that was something you could do, but I guess it's there's a way around it somehow. Okay, well, thanks a lot. Yeah, again, thank you very much. That was a very good presentation. I appreciate that.
You can probably do it on GitHub as well. If you go onto GitHub and then open the Python folder in GitHub, you've probably got all the scripts there.
Oh, I see where the actual repository is. Okay.
Yes.
That's an idea. Great, thanks.
Yeah, Ted has just put a link to that GitHub repository in the chat. Okay, thank you very much, Adrian, and thank you, Andrew. Dave, anything else you'd like to mention?
No, not really, Andrew. I'd say thank you very much to Andrew. Superb presentation. On sort of a slightly funny note, because I didn't have my speaker going right at the beginning of the meeting, I hadn't realised we weren't trying to follow on. And while you were talking, Andrew, I was frantically trying to punch it all in as you were going, not realising it was just you were just describing it, and we weren't meant to follow along. But I realised after a bit, after I fell behind. But anyway, yeah, fantastic. Thank you very much. I really enjoyed it, and you could go back and when the video is posted up, listen to it all again. I think it's really, really useful. Thank you.
Fantastic. Well, you can distinguish between the two of us if you want there, Dave, by saying Andrew with hair, that's him, and Andrew without, that's me. Although he's going the same way, but
absolutely, yeah.
He seems to preserve a bit more.
Yeah.
Okay, brilliant. Well, thank you very much. And Andrew, is there anything else you'd like to talk about this evening or mention? Oh yeah, brilliant. So that's your interstellar visitor from last night. You've gone quiet. You're
Sorry, I muted myself. Yeah, that's from C-Star 50, the Interstellar Object 3i Atlas, last night, because it was clear sky. So it's that bright object in the middle.
Wonderful. What time of the evening were you taking that picture?
That was at midnight.
Ah, okay. In the unlikely event it's clear at midnight tonight, I'll pop out and have a look.
Yeah.
Brilliant. Well, thank you, everybody. That's I think been, and thank you very much to Andrew again for such a fantastic presentation. I think that certainly has helped me progress and improve. And thank you all for coming along to this meeting so close to Christmas as well. That was brilliant. So, should we set a date for the next meeting? Are we still happy with Saturdays, or would we prefer a different day of the week? Well, okay, we'll stick with Saturdays then. So we're currently the 20th of December, so exactly a month's time would be... Oh, it can't be the 17th, at least I can't do the 17th anyway. Excuse me, of January. How about the 24th of January? How would that suit people?
I can't do that one, but it doesn't matter.
Oh, it does. Of course it matters. Well, we go the other direction, 10th of January.
I can do that, or the 31st.
Or the 31st. Any particular preference from anyone?
I go 31st. Gives us more time to prepare, especially with your homework.
Okay, 31st then it is. 31st. So 7 o'clock, 31st, GNU Radio. I'll for anybody who's interested in having a go at the assignments, or either one or both, I will send them to you by email, but they'll also be there visible in the video itself as well. And as I say, don't feel in any way obliged necessarily to do them if you don't want to. And if there's something else that you'd rather do instead, that's absolutely fine too. It's always an opportunity to show them here. I mean, clearly we're moving slowly towards producing GNU radio scripts that are directly relevant to radio astronomy, because that's what the group's all about. But at this stage, I don't think that's required, as we're quite early on. So for those people who just want to produce something more simple, that's absolutely fine. And that's really where Andrew and I have been starting with some of the sessions. So thank you very much again for coming this evening, and I wish you a very happy Christmas indeed, and look forward to seeing you next time in the new year. Bye bye for now.
Bye.
Thank you. Have a great Christmas.
Thank you.